At today's office hours, it's kind of going to be a Chandrika show. Chandrika and James for the weather agent, and then Chandrika is going to talk about PyTest for Voltron agents. So why don't we start with the weather agent, Chandrika?
Sure.
So some quick background. A few months ago, Weather Underground got bought out, and they stopped giving out new free weather keys. And we didn't want that to be a barrier for people to use weather on Voltron. And so we talked about that a couple times on this and in some other contexts, and have been working on a new weather agent that's much easier to swap in and out different solutions. And with that, I'll turn it over to Chandrika.
Okay. I'm going to share my screen. Let me know when you can see it. Are you able to see my screen?
Yeah, we can see it.
Okay. Okay. As Jeremy mentioned, this was mainly started because we couldn't use the free API keys for Weather Underground anymore, which also got us thinking that okay, maybe we should give the option of using more than one, or be able to pick between different weather providers, and so come up with a generic class, like a base class, and then different implementations of different weather providers can be subclasses similar to historian. And that's what we went and did. So right now what we have is a base weather agent, which does lots of common useful things. The main important thing it does is caching. And this is useful because even the weather providers that are free most often would restrict the total number of requests that you can make in an hour. Some restricted by hour, some restrict by day. So if you have multiple agents trying to get the same data, and say the weather forecast is not updated, is updated only every hour by your provider, and you don't want 3 or 10 different agents trying to get the same weather information forecast for the same location, and each one going in as a call to the remote provider, thereby reducing the total number of API calls that are available in that hour. So that's where caching can be really helpful, and that's how we implemented caching in the base. Another thing that we did was the ability to map the names from whatever the provider returns to a standard name. For example, if your provider returns a data point saying heat index is so-and-so degrees Celsius, or but another provider might call the same thing as, say, apparent temperature, and somebody else might call it as feels like temperature. And if you're getting data from more than one provider, you might want some way to say make all this standard. And so the base weather agent can get your result and then parse through your result, your data point name, and map each point name to a standard point name. Kind of like how we use the device registry for how master driver uses the registry configs. So similar to that, you could map a given point name to a standard point name. The third useful thing that the base weather agent does is unit conversion. So if you have, not everybody provides in a standard, some people follow metric, some imperial, some are mixture of both based on what data they're returning. So it's always good to be able to convert it on the fly, to a standard units that your application is expecting the data in. So those are the three things that the base agent provides. James, did I miss anything?
No, I think those are the
basic
things, yeah.
Okay, yeah. James is also another developer who's worked on this. So James, if I miss anything, feel free to jump in and add to it, or correct me if I miss something.
Sure.
Okay. The first implementation that we've done is for data from weather.gov. And this is primarily for data that's from within United States. But we still did this as the first implementation because weather.gov data is free. You don't need an API key. There are plus and minus to this. The plus, of course, being that it's free. You don't need an API key. And so to start with, you have something that you can just use. But the disadvantage is that they do not provide history data, and we do. Well, like while testing, we found that we do get timeouts every now and then, like maybe twice a week or something. When we try to access the data, we just get a timeout. It's not often, but it's something to be noted, saying that okay, it's not like 24/7. It's not. So there could be plus and minus. Again, every data provider gives different set of data points. So if you say current, give me current weather information. One provider might give you, 5 different things, like say heat index, temperature, dew point, relative humidity, blah blah blah. Point 1 to 10, but somebody might give you 20 different things. So that's also a difference. Reason why you might pick one provider versus the other, or you might want to run more than one instance of weather agent, and so that you can get all the data combined and get all the data together. So I'm going to show you a simple example of the current concrete agent that we have running. So I'm going to start my Voltron. I do not know if I already have have an instance running. If so, I'll remove it and install it again so I can show you the config. Okay, so this is a sample configuration file for the weather agent. This weather.gov has ability to get you current weather and forecast. And for current weather, it expects the input to be in the form of station ID. They have different station IDs, and you can query the current for station each by giving the station ID. And for forecast, I think you can either give a station ID or a lat long. James, am I right?
The forecast expects a lat long or a sort of more strange and hard to understand thing called grid points, which includes a string of characters that I'm not terribly familiar with, and then some sort of modified lat long, or actually it's grid points, so it's like a
grid points. Yeah.
Yeah.
Okay.
If you're not happy with the grid points format, it doesn't really matter. The request forwards to that anyway, so you don't have to deal with it. You can just put in a lat long and call it a day.
Okay. So for current, it's station ID, and for forecast, it's lat long.
Right.
Okay. So weather agent also has the provision of there are 2 ways you can access the data through the weather agent. One is periodic polling, and periodic polling would only do poll for the current data. It will not do forecast. Or you can do an RPC call to get that current or forecast data. So first I'll show you the polling, and for polling, you could have more than one location for which you want to poll for the data, and you could have the data, the result posted to all of them in a single topic, or each one to a different topic. So if you give this parameter poll topic suffix, it's going to post it to weather slash current slash poll slash response one would have all the details of this station ID, and similarly response 2 would have all the details of this. And if you don't have this poll topic suffix at all, it'll just post it to a slash all topic, and it'll post an array, essentially one for each location. And poll interval is a mandatory parameter which says how often you want to poll for the data. For weather.gov, this might not be critically important, but if you're using a provider which has like restrictions on the total number of things that number of requests you can make. You might want to be you might want to compute this based on what your restriction is for your API key. Okay, so I'm going to install with this. Agents. And -c config test. And I'm going to have, okay, I already have a listener, so I'm going to start both the listener and the weather.gov agent so that I can see the messages that are posted to the bus. You can already see one set of data posted here. Whoa, that scrolled by pretty quickly. I'm just going to show you that. Okay, you can see that for response 2, you got the station KBQ's data, which contains air pressure. Air pressure, that means sea level, wind speed of gust. And if you notice, all these keys is what got mapped to a standard name. We have in the code directory, in the weather.gov agent data directory, there is a name mapping.csv. You can call it whatever you want, as long as you point to that file and load it in one of the implemented methods, which the base class is going to call your concrete class saying, give me the mapping file, and you return your mapping file to it. And you can see that, say, wind, what would be a good example? Say, wind gust is mapped to wind speed of gust. This might be a good example. So this is a wind direction, and the standard has two names. There's a wind to direction and a wind from direction. So in this case, this is mapped to wind from direction because that's what weather.gov returns. So this helps it make it more explicit, saying what this wind direction means. Is it a from or a to? Similarly, sea level pressure, is it mean pressure or not, what level? Things like that. So
the mapping that we're specifically using is based on a pretty well-defined set of weather data points, which
that's a good point.
Kind of recommend using.
Yes, this is the standard that we're using. We also have a link to this in the specification document for Weather Agent. So this is a pretty exhaustive list. It maps, and it has all the definitions of it to be sure, and this is what we use to map it. But again, if you see something missing, you can always come up with add more standard names, because that particular CSV file is controlled by whoever is developing the concrete agent. It's not a part of the base agent. Go ahead, James. Were you going to say something?
Yeah, you can probably tell that the CSV also contains the ability to map to different kinds of units. Again, we kind of recommend using the specification that Chandrika just showed you to choose your units, as those are kind of accepted international standards for those particular points. But of course, you can choose whatever.
Yeah. So you could map units. One thing about units, though, it's like what the base weather service does is that if you have, like, say, heat index : a value, then it takes the value and converts it into the standard units. But if your value is nested deep into, say, a nested dictionary which says heat index colon another dictionary which says, actual value without units equal to 15, value with units is 15 degrees Celsius, something like that, then it's not going to parse it, because that's specific to the concrete agent. And if there is things like that, then that should be handled by the concrete agent and not the base weather service. Okay, so any questions so far? Okay, we saw the polling. Now I'm going to call the same functionality from a different agent, and for that I'm going to use a standalone agent. There is an example of a standalone agent under Voltron examples. Where is it? Yeah, this one. And I took that and just created my own, just so that I can make calls to the weather service agent. A standalone agent is a subclass of agent, which is what all Voltron agent subclasses, and it still requires the same set of libraries that other Voltron agents need. So you would want to run it from a Voltron activated environment, but a standalone agent need not be installed within Voltron. So if you have all the Python dependencies of Voltron in an environment, you can run the standalone agent just as like a Python script. And it can interact, it can make RPC calls, or it can do a publish and subscribe to the message bus, and it can interact with Voltron, though it's running outside of Voltron. So that's what I'm going to use to test this. And as a part of this, I'm just going to show you how to set up a listener agent, standalone agent. So you can use this template to write, to modify, and all the main activities that you want to do, say for example, calling the weather agent or subscribing to a topic, all those should happen in one of the lifecycle methods of an agent. For example, a periodic call, or a method that is decorated with on startup or on setup, so that when the agent runs it, and it's part of the agent's lifecycle, and your method would get called. So in this case, I'm doing the RPC call to the weather agent in a periodic call. So every 10 seconds, this method is going to get called, and it's going to make an RPC call to the weather agents, get current weather and get hourly forecast. So that's what this method is doing. And in order for this agent to run, there are a few prerequisites that you have to do. First, because this agent is running outside of Voltron, your Voltron instance, you should make sure that your Voltron instance is using a TCP address and not the default IPC. IPC is interprocess, but this is running outside of the Voltron process. So you want to first run your Voltron instance in using the TCP address. And to do that, either you can run Voltron configure, or you can just make sure that in your Voltron home config file, your VIP address is a TCP address. Once you have your TCP address, that means your Voltron is accessible by external process, and you want to configure your standalone agent, and all the configurations of the standalone agent is there in the settings.py file, and these are the parameters. So this is your Voltron IP address and port, and you want to generate a public private key pair for your agent, and you can do that using Voltron control auth key pair. So just running the command now, control, this just generates a public private key pair. So you can use that in your settings. And then the next one that you will need is the public key of the Voltron instance server that you're connecting to. That again can be got using the Voltron control auth command with the server key options. So Voltron control auth server key gives you the server key. And this is another setting that you would need because your standalone agent needs to know what instance that it's talking to. Once you have these settings, what you want to do is update the Voltron instance auth to allow access to your standalone agent. In order to do that, you want to run the Voltron control auth add command. And this is all documented in the standalone agent, so you can use that as a reference. So I'm just walking you through it. Voltron control add. When you're prompted for address, this is the address of your Voltron instance. And when you're prompted for credentials, this is the public key of your standalone agent. So this matches your settings.py public key here. And once you do that, Voltron will make an entry in its auth file saying this agent with this public key can be allowed to connect to me. Once you do that, you should have your weather agent running so that your standalone agent can talk to it. And then after that, all you have to do is run the script, Python, whatever your name of your test script. So which is what I'm going to do now. So from Python, let me make sure I'm running control. Okay, my weather agent is running and its status is the health is good. And now I do Python examples. What is the stand? There. So that's what it did. As soon as it started, it first made an RPC call to get the current data, and then it went and made the RPC call for forecast. So it's just showing forecast results here. So if you see in the current data, this is pretty much the same thing that your polling returned with the same kind of information like air pressure mean at sea level, dew point temperature. So two ways to access the same thing. There's one more small thing that I wanted to show, which is about the status of it. So if there is something wrong with your configuration in your agent, the status would report as bad, and what exactly went wrong would show up in your log. So currently it's saying your health of your status is good. So let me do one thing. I'm gonna say test all, and I'm gonna give some invalid entry here, just so that I can show you the status reporting. Okay. And now if I do, come on, there. And start. And so it says, the agent is running, but your config status is bad. And if you go and, I don't know, let's see if that's enough to show. There, it says fail to load weather agent setting with error. Poll suffix if set should be a list of string with the same length as poll location. So if you if you want to see control what topics the results are posted to, then you should have one suffix string for each location that you're trying to poll, so that it'll post it to the corresponding location, or it'll be a single topic that'll be like /all. So that's the error that it's showing. So that's pretty much all I wanted to show for weather agent and the standalone agent. Any questions? Okay. James, did I miss anything? Do you want to mention anything else?
No, I think that was very thorough.
Okay. And I think the standalone agent in develop does not have like the detailed notes that I made for myself when using the standalone agent. I will commit it to develop. Yeah, Craig just asked me, is it out there? There is a standalone version. It has some documentation, but it does not have examples for what to do with the bolt-on control auth add and stuff. So I will update and create a pull request to get this into develop. Okay, so anything else, or should I move on to PyTest? Jeremy, do you have anything else to add?
So yeah, does anyone else have a favorite weather service, or does anyone else have any comments on this weather agent?
Yeah, that's a good point. Does any like we are using weather.gov, but we're not like we do, like I said, we did see like periodic timeouts, and then the data that's returned is not very exhaustive. Though if you go to actually the website, there's lots and lots of weather data, but not all of them are accessible using the API or automated through an API. So you can always go request and download a data set and stuff like that, which has like lots of data. But what is returned by the API is pretty sparse, and they're like only a handful of data points, and some of them come back as empty sometimes, like none values or empty values. So is that going to be a concern? Is there some specific data point that you like, that you think weather.gov might not be able to give you?
Have you tested this out with Rabbit?
No.
Okay.
And with respect to status of this there is since weather.gov does not give history, there are not many test cases around history. The base does have some history handling code, but there's not extensive test cases for it, and we have to still update the documentation. I mean, there is an initial documentation that was created, but I mean, it has to catch up with whatever code updates and testing updates that we did. So those are the two pending things before we can create a pull request to put this into develop. But the plan is to just comment out maybe history part completely, and then do one version, and then fix the history. Maybe if somebody has other weather provider that they like, we could do a second one possibly, and then test history with that, and then create a second version of it next round.
This is Jens. I just have a quick comment. I have recently worked with PVLib. This is a solar forecasting library. I think it's from Sandia Labs, and they use something called Siphon to access weather forecast data, and that seems to be pretty sophisticated. So you might want to take a look at this Siphon library as well.
Is it a Python library, or do you know what's?
Yeah, it's all in Python.
Okay.
Could you?
How do you spell that?
Yeah.
Siphon.
Oh, okay. Sorry, I was here. Scython. I was getting.
Oh yeah.
Yeah, which is totally different.
Yeah, my German accent.
No. And we're hearing what we're expecting to hear.
Yeah.
Okay, I haven't looked at it, and I don't know. It's a Python library, but I'm wondering where the library pulls the data, like the weather
Well,
data from?
the library gets the weather data from NOAA. So
Oh, so it's
the ultimate
weather.gov data,
source
yeah.
might be similar to what you're using here, but you might find some benefit in using this Cython library that they based this PVLib on.
Okay. PBlib.
PVLib.
Okay, PBlib. Okay.
You can find that also on GitHub.
Okay. I will take a look to see if they do anything no more, like if they do more processing or error correction and stuff like that for the data, or if they, I don't know, if they use different APIs that we didn't find, maybe. Yeah, because they do have a lot of data. I wish there were better way to access the data that NOAA has.
Yeah, so for example, with this PVLib layer on top of Cython, you can easily switch the weather models. For forecasting, you can go from high resolution, low resolution, and you can switch between near forecasts and long-term forecasts. I don't know what they do about historical data. This might be in there as well, but I don't know anything about that.
Okay. I will take a look. Thanks. Any
other comments?
Any other comments? Yeah. And if there is somebody who can verify the mappings that we did, like I'm no weather scientist. Many of these terms I Googled for the first time. I have no idea what it even meant. So like now if anybody can take a quick look, once we push it to developers, if somebody can make a quick look and see, okay, this mapping is right. I mean, the definition is correct and I didn't map something wrong to it. That would help too.
Yeah, we're definitely looking for feedback from anybody who's interested in using the weather agent. So, okay. No other questions on that. Then, did you want to head into PyTest?
Sure.
Okay.
Okay. I think recently we had questions about, going over PyTest to how do we write test cases for agents, and how do we test. In Voltron, we use the PyTest framework. PyTest is a unit testing framework, and I would highly recommend it. And if you are not already using PyCharm for your development, that's again another thing that I would highly recommend, because it makes life so much easier to just debug and step through. It's so much more easier than to set up a debug trace or look at the logs every time to print and log. Okay, so let me open up PyTest, and then you can see already I have so many debug points when I'm testing. Okay, for PyTest, any method that's starting with any class that has like a test underscore something, or any method with test that starts with test underscore something would be considered a test and would be run. And for PyTest, the nice thing is that it has what is called as fixtures. And a fixture is essentially a method decorated with the decorator PyTest.fixture. And every time your test method uses a fixture, it'll go to that particular method, run that method, and whatever it is returning, that method is returning, that will get accessible, that will be passed on as a parameter for your test class. So for agents testing, what we typically do is that we have pre-existing fixtures for that can mock the Voltron instance itself or the Voltron platform itself for you, thanks to Craig, who wrote the platform wrapper. there's a module called Platform Wrapper, which does all the things that we would typically do on a Voltron on command line. For example, install an agent, start an agent, stop an agent, remove an agent. All that are methods of this Voltron wrapper. And that wrapper is available to you as a fixture called Voltron instance. And I will show you where it is. So Voltron platform fixture. So this is a file that has many useful fixtures for testing, creating PyTest and running them within Voltron, because this gives you instances. So for example, if you want to use the web, then this instance has web enabled, and if you want multiple instances, then you can I think there's the Voltron instances, right? Yeah. So this can give you more than one Voltron instance. So what each of these fixtures, say for example, the most important one, I would start with the first instance, one instance, a single instance. So this is a fixture, a Voltron instance fixture that essentially creates a Voltron wrapper and returns that wrapper object to you. So when I test, say the weather agent, I need an instance of Voltron in which I want to install my agent and test. So I call the Voltron instance fixture, and then I can use that instance to install my agent, start my agent, or no, at the end of my method, stop the agent. So this is something that you would want to import. And in this case, for example, I'm testing the weather agent. So I have a fixture called weather, which is going to get the instance, get a Voltron instance, install the weather agent, the test agent that I want to test, and then return that agent UUID whenever any test case access this weather fixture. So in my test case, saying say test success current, and in this I have a weather agent, weather as a parameter passed. And because this weather is marked as a fixture, what PyTest is going to do is it is going to run this method, and whatever it's returning, it's going to pass that as a parameter to my test case. And another fixture that is useful is you need an agent class to invoke your say RPC calls of the agent that you're testing. So in my case, I'm testing weather, but I need an agent to call VIP.rpc call the weather agent's method, right? So this agent, I have another fixture called query agent, which is creating an instance of the agent class for me. Again, I use the Voltron instance fixture to create a mock agent. So
the Voltron training.
So, sorry, did somebody? Oh,
I think
okay.
someone's talking.
Via Zoom.
I think so,
Okay.
someone that might need to mute yourself. I think you're having a side conversation.
Where are they?
There, I took care of it.
Okay.
Go ahead.
Okay. So the Voltron instance has a build agent method, which would give you essentially an instance of an agent class, which is like your fake agent, or that is just it's just an instance of an agent class that you can use to call things like VIP pub subscribe, or RPC, make your RPC calls. So this is another fixture that you would want to use in your test cases. And for PyTest, all these fixtures can be marked as with the scope. And when you say a scope is a module, this particular fixture will be run only once for your entire test module. And no matter how many test cases you have, it's going to create a single instance of this agent and use that agent class for all your test cases. So a fake agent that you use just to call the RPC methods or subscribe would be a very appropriate fixture that's to be scoped at a module level. There are other fixtures that you can scope at a function level, which means for every test method that's calling it, for example, in this case, a cleanup cache. As I said, the weather agent would cache anything that every time you query, it puts the result into a cache so that the next person does not have to do a remote query. But when I'm doing tests, I don't want the entries in cache to have an effect on the next test case that I am running. So I want test cases to run immaterial of what order it is run and whether it is all run together or run only one at a time. So what I do in my tests is that I clean up the cache after every test. So, or before every test for that matter, so that I start from a clean state. So I have a fixture called cleanup cache, and this is something that's a really good example for a fixture that you would want to have a function level scope. So every time the cleanup cache is passed as a parameter to my test method, because the fixture is marked scope function, it's going to call it, execute the whole thing. And so in my cleanup cache, I have connection to my database, and I'm just doing delete. I'm just truncating all tables so that I start from a clean state and I have a clean environment for every test case. So that's another thing to know. And another very, very useful thing is that you can have parameters to your test cases. So for example, I said for test case, I'm trying to test the success case of querying for my current weather. So I have a weather agent, which matches a fixture called weather. So PyTest will go execute it. And because the scope is module, it will do it only once. So I have only one instance of the weather agent that's going to run, that I'm going to use for running all these different test cases. And then there's a cleanup cache, but that is scoped as function, so it'll run it for every test case. Then I have a fake agent, which I use to make the RPC call. And this locations is not a fixture, but it is a parameter. So in PyTest, you can say parameterize this function with these variables. So for example, I'm saying, look, pass locations. These are the list of possible values for the variable locations. So the first time PyTest would run this with the first entry, then it will repeat running the same test case with the second entry. So this saves you from writing the same assert statements twice, once for this location, another for this location. So if I have similar behavior, it's extremely useful to parameterize this and say, okay, first time run it with this location, second time run it with this location, and based on what is run, what is the current value of this, that will get passed to this location. So this location matches this. So all I have to do is I'm saying assert my length of this result value is the same as length of location, because I'm expecting that every single location is processed and I get the same amount of result, one for each location. And for each location's data, I put it in a for loop and say, okay, assert that it has observation time and weather results and everything. So that's another useful feature to remember. And this is also, this parameterize can also be used at the fixture level. So suppose I have this test case to be run for these two, but also run the same for, say, 2 different weather agents. So I could have here 2 different services, another, I don't know, dark sky service. And that way, then, because this test case uses the weather fixture, this particular test case is going to be run 4 times. Once for the weather.gov service with location this and this, then again repeat the same thing for dark sky with this location and this location. In this particular case, maybe it doesn't make sense because you have a station ID, but if it's something like zip code 99353, then it makes sense that because if you have two weather services that can handle zip code, then you're expecting similar results. Then you can have one fixture that is parameterized for the two different weather services, and you can have a test case that is parameterized for two different, say, zip codes. So far, so good. Any questions? Okay. I would take that as a no. Okay. And this parameterize can need not be used just for different inputs, but you could also use it to have more than one variable here. So you could have an input and an output. So I can have locations, this, and I can have an expected output variable now, and have a list of outputs. So I can say if it's this location, I should have this output. If it's this location, it's this output. I think I already have an example of it somewhere. Let's see. Do you remember one? Yeah, there. So for this config, this is, for example, the polling one, right? So we said we saw polling, and we said when you're polling for multiple locations, and if you don't give a poll suffix, it's all going to get posted to a /all topic, right? So in this case, I'm saying the input is configuration, and I'm also having this is the expected result is there in this result topic. So this is in our nested list. So the list of expected value is like for this config, this is the result, a topic to which the result should be posted. If this is the config with which my weather agent is starting, the results should be posted to these two topics, one for this and one for this. So in my topic, actual assert statements, I make sure that my result topic matches this. Should I talk about the mock? Do you think it'd be useful, or is it going to go? Am I covering
a quick yeah,
mention of it would be okay.
what it does and things, yeah.
Okay. When you're testing with RPC calls, it's pretty straightforward to test. Like, so for example, in this case, you have a query agent, which is just you did a Voltron instance.build agent, which gave you an instance of the agent class just for doing queries. It's not really it's not a real agent that has any functionality. It doesn't do any specific functionality like historian or weather, but it's just an agent class so that you can access this. So testing RPC calls is pretty straightforward for it. So because when you do an RPC call, you get the result, and then you can write a bunch of assert statements saying, okay, my results should contain this, my result format should be this, my result length should be this. So that is pretty straightforward. But when you want to test something, in the case where the result is published to the message bus and not an RPC call, then what you want to do is that you want to capture the results of the message bus. So when you subscribe, I'll show you that, query agent subscribe. There, okay. So when you subscribe, so in this case, I want to test the polling. So I'm saying whether poll current, subscribe to this. And I said, whenever this message is there, this is my callback method. But I don't want to implement the callback method because all I'm trying to test is whether the callback happened, and what happens within the callback method is the calling applications logic. It's not the weather agent's logic. So I only want to test whether the callback happened. So to do that, we use what is called as mock. This module helps you to mock any functions or classes. So I'm saying this agent has a function name called poll_callback, which is not an actual function, but it's just a mock object. And whenever there is something posted to weather poll current /star, it's going to call this poll callback. But this magic mock library helps me to intercept not intercept, actually to investigate what exactly how many times it was called and with what parameters it was called. So when I do poll callback, where am I start using for it? Okay, so this is what I'm doing. So because it's pointing to a mock object, it gives me access to methods like give me all the call count. So this will tell me how many times it was called. So if I'm polling every 10 seconds, and as soon as the agent started, before 10 seconds, I should have had exactly, say one call for each location if I'm pointing to different topics, or if there are 10 locations, and if the result is getting posted to an all topic, then I should have exactly one call to the callback method and not more than one. So I can do, say, query agent.poll callback.call count is the same as whatever is my expected length of my result topic. So if my result topic is just the all, then I should, in middle of how many locations are there, I should have got exactly one call. And it also helps me to access the call args list. So this will show me what are all the arguments or what was the message that was posted to that particular topic. So I guess I could, we can put a breakpoint at this print statement and we can show this, I guess. Oh, this is another nice thing that I can mention. Let me finish this and then I'll. Oh, and I'm running all this from PyCharm because then it's easier to debug. Oh, that is taking a while. Oh, the test for market service agent. Okay, there, see. So my agent has started and I've got a callback. So if I, 6, console. So this, I do not know if this is readable by everybody, but it says, okay, this was called, these are the arguments that were passed to my callback method, and that shows pretty much everything, the results, right? So I can say, okay, was the result correct? So this shows the current data with the weather results. And the weather results, all the data, dew point, temperature, humidity, everything. So it's as if you had an actual method, and the method had whatever parameters with which the method was called can be accessed using the call args list. Okay. So that's a very useful magic markers, a very useful library to have. And I do not know if you had noticed, what I did was to run just this particular test case, I marked the test case with a tag. So you can tag test cases with a marker and run just that test case. To run PyTest from PyCharm, which is extremely useful and I highly recommend, is that you configure in settings. In settings, yeah, in testing, okay, I think my default, you can set it to PyTest, though I did not, but that's okay. And then in your run configuration, you can point to your home directory. This is the directory in which I have checked out my Voltron. This is my Voltron source root. And this -m tells what marker test to run. So I said, okay, run only the test case that are marked with the marker dev. Or if I want to run all weather test cases, I've marked all my weather test cases with this marker weather too. So that way I can say, okay, if I do some changes, I want to make sure nothing is broken. I don't want to run all the test suits of all agents, but I want to test only my agent then I just say run all test cases with the marker weather too. This is extremely useful. And with PyTest, you can also do one more thing, which is, okay, you ran something, say 3 test cases failed, and you went and fixed stuff. Now you want to run only what failed last. You can add the argument dash dash last failed, and that way it'll run only those test cases that failed the last time you ran. So PyTest has so many of these nice, extra bells and whistles that come in very, very handy when you run test cases. Anything else?
How do they enable test cases? Because PyTest isn't installed by default.
Oh, yes, that's a good point. So when you do a bootstrap, if you run it with dash dash testing, that should install PyTest mock object, and there are a few other, PyTest timeout kind of extensions. I think those are the only 3 things, but I could be wrong. Testing, yeah. So run it with dash dash testing, and that'll install all the necessary dependencies for PyTest. And you can run it from command line too. You just have to run PyTest -m. What did I run? Dev. Yeah. So you can run it from this too. So it'll collect only what it is doing when it says collecting is that it's trying to find what all tests have the marker dev, and it's running only those. And what else? So it passed that. So, and it'll do pretty much the same things that you saw.
So the dash S that you put in there, that would allow standard out?
Yes. So by default, PyTest would wait till the end. After running all your tests, it'll give you the entire std out and std err. But if you want to see the std out and to scroll as the tests happen, then you have used the -s option, which I found. Yeah, I never run it without -s.
You just did in the command line.
Oh, did I? I'm sorry. Well,
no,
I rarely use.
You meant to do that, right? It was
I never
conscious.
use command line, so yeah. Sorry. I've been spoiled by PyCharm because it's already always saved for me. So pardon me. Yeah. So this is all you need. You just need the script path as your source directory, your working directory as your source directory. Oh, another very, very important thing is if you set the environment variable debug mode equal to true, then Voltron test framework will not delete the temporary Voltron home directory that it created for the test. So every time you run, the test creates in your temp directory, it creates a Voltron home directory, installs everything within it, and tests within that. So so in my, I'm sure I should have lots of cd temp whatever 3, 4 something. So this is one of the test directories that when I ran the test case, it generated this. So this is your Voltron home, and if you don't have debug mode equal to true, at the end of the test, this gets deleted. But if you want to say if something is failing, and if you want to look at the logs for more details, then the log gets created within the temp Voltron home. So you run it with the environment variable debug mode equal to true, and that would preserve that temp directory. So you can, and if you go in as your whatever test run, and you can see the temp directory. So this is your Voltron home. So you can cd into it and then look at the logs, and there'll be a Voltron.log in it, and you can see that. Look for any errors and debug. That's another way to debug if you don't want to put debug points. And all the markers are mentioned in a file called pytest.ini. So we have for each agent, we have a logical markers, and all those test cases are marked with that. So that, if you want to run all historian test cases, you do, pytest -s -m historian, and it'll run all the test cases for all the historian test cases. And
a test can have multiple markers.
Yes.
It doesn't just have to have one.
And there is a dev marker, but please do not check in anything with this dev marker. This is pretty much used only for like temporary. So if I'm debugging something, if I'm developing, I want to run just that one thing that I broke, then I mark it with dev, run it, and then before checking in, I remove that marker completely so that others can use it. Yeah. Anything else? Oh, I've been talking for a long.
I was going to say that the dev marker might not be might be obsolete, because I know that you can specify a specific test that you want to run from the command line. But
Yes, you can
way.
do a.
She doesn't
You can do
want
a
to have to remember that though.
name. That's true.
And then she
Okay.
just has the shortcut that goes mdev.
Fine.
Yeah, if I have a dev, then I get to have a configuration permanently here, and I can run it, and I can run more than, like, if I broke 2 test cases, I mark it with dev.
Oh, that's a really
instead
good
of-
point.
Yeah, but if you could do, if you know a particular test case by name, then you can do -k and give the name of the test case and run it. But I don't want to type test_success_ multiple location. It's easier to type test -mdev. But yeah, it's personal choice, I guess. Yeah. But yeah, the PyTest gives you a lot of options to pick whatever makes your life easier. But it does give a lot of options, and that's why PyTest is awesome.
All right, cool. Well, thanks. If anyone has any questions about this or any other topic, go ahead and email voltron@pnnl.gov. If you have topic suggestions for future office hours, also please just let us know that, and we're more than happy to take requests. And we're definitely interested in hearing any research that anybody on the call wants to share. So with that, I know we're over time, so say thanks everybody for attending, and hope to see you again. Let's see, next, did I cancel the next one because of
Thanksgiving, yeah.
Thanksgiving, yeah. So the next one, office hours is canceled, but we'll do, the next one will be December 7th. All right, thanks everybody.
Thanks, thank you.